Hi, I'm James McGuire, and on today's eSpeaks, we're talking about infrastructure observability. In other words, being able to see what's really going on with the connections, the software, the hardware, what's going on in the system that supports your business. To discuss that, I'm joined by Amit Agarwal, president of Datadog. Amit, very good to have you with us today.
Thanks for having me, James.
So, obviously, infrastructure observability has been really a pretty hot area the last couple of years. It feels like it's really come on strong. You're obviously very close to the market. As you survey the sector, the market for infrastructure observability, what are a couple of key trends you see driving the sector?
There's two key secular winds that are working in this sector that are in our favor. One is the number one trend is this whole drive to digital transformation, which is mainly around companies transforming all of their processes, systems, and so on that were mostly done manually with human intervention, to turning them into applications that their customers interact with directly over websites and so on, which means that they have to monitor all these things, and they need to monitor the systems that these things run on, these applications run on. Second part of this is specifically the cloud, because all of this digital transformation is now happening in the cloud. And that means that there are many more things to monitor, many more things to look at, because cloud environments, as you know, are highly ephemeral, highly dynamic, highly scalable. So, which means that people have to look at understanding how exactly things are performing, where things are working, where things are not working.
Am I correct in thinking that observability has been a trend that has grown the last 2 or 3 years? Because as long as I've been covering tech, which is quite a while, I don't remember there was a lot of talk about observability back in 2014, 2015. Did I just miss it, or has observability really come on strong in the last couple of years?
Well, the term observability has come out in the last 3 or 4 years, but the underpinnings of observability, many of the things that were in observability have existed as long as computers have existed. So we used to call it monitoring back in the day, where we have always monitored the health and availability of computers that participate in important business transactions, whether it was mainframes back in the 1980s and 90s, to the distributed systems that came about in the 2000s, to now in the cloud environments. What has changed, why this is called observability now, what has changed is many, many more business critical applications are being run at scale, where these applications have become your storefront, they have replaced your brick and mortar stores. So what used to be the domain of very technical engineers who are just looking at technical metrics like CPU, memory, and so on, has now transformed into businesses looking at this digital storefront that they have as a way to understanding how their business is performing. So to give you an idea, let's say you're an e-commerce website. Before, it used to be the e-commerce website used to be the storefront, the brick and mortar storefront.
Right.
So Black Friday, you would see a mass of people come in, and business would be very interested in understanding how many people came to the store, because that was the biggest day of the sales, right? Like biggest day. So they wanted to know how big these sales were, et cetera, et cetera. Now with a digital storefront, like an e-commerce site, the business is now interested in both making sure that the site is up and running, because if it goes down and that's driving 70% of your business, you need to make sure that it is up and running, right? Like, so monitoring has taken on a new meaning, right? Like it's not just, oh, we'll have to restart everything, it'll take a couple of days. If that day is gone, it's the whole 20% of your annual revenue gone, just like that. So taken on more new meaning in terms of monitoring and observability, observing what you look at. And then second part of it is that the early indicators, the operational data that you get from these applications that point to both the health and availability of the applications are also the same things that the business cares about. The business cares about because those are also the leading indicators of how the business is performing. So for example, a network engineer might look at the number of network connections that are being made to an application. But these network connections, each of them could individually represent a different customer. So the business is also interested in understanding how many customers are on the website buying things right now. So in other words, it's gone from monitoring very technical metrics, which are hard to correlate to the business, to these metrics being the proxies for the business itself, and the business being very interested in these metrics. Hence the term observability, hence the deep focus and interest from everyone in the last few years as companies have transformed themselves.
Right. Okay. So really, observability has risen with the very idea of data and metrics, which has risen very, very much in the last few years. So what do companies struggle with the most when it comes to observability? I think there's companies that are very keyed into being better at observability. Why is it hard for companies, and what's a typical pain point for them?
James, there are several. So one key pain point for companies is just the volume of data that can be observed. The volume of data that can be looked at is massive, right? Like massive volumes of data and making sense. So because you can now instrument and monitor everything, right? From every line of code that's running in your environment, how many times that line of code runs, to how many containers you have, how many pods, how many servers, how many serverless functions, et cetera, et cetera. So there's a massive amount of data, and it's being produced by a very distributed type of application architecture. Because, you know, back in the day, in the 1980s, you used to have one big mainframe, and that used to run your entire application, and that was the only thing you had to monitor.
Sure.
Now you're talking about a widely distributed, microservice-oriented, container-oriented architecture with lots and lots of things participating in it, each doing its own little sliver of a task. And you need to be able to understand how these things are interacting with each other, which things are up, which things are down, which produces massive amounts of data. So for customers to understand this, to make sense of all of it, to find the needles in the haystack when there is a problem, is very challenging, and that's a key problem that companies are facing.
All right, so let's talk about Datadog itself. I mean, Datadog is launching cloud cost management. It's a product which unifies cloud cost data and cloud monitoring in a single view.
Yep.
Clearly, there's a demand for that. I mean, but the question is, how is this different from competing solutions?
That's a very good question, James. So you know, and to give you an idea, Datadog itself is a SaaS-based, cloud-native company. So all of our products run in the cloud, and some of the problems that we're solving were problems that we faced ourselves internally at Datadog as well. So these problems are related to companies moving into the cloud, right? Like we talked about how many companies are moving to the cloud. So companies moving into the cloud meant the reason many companies moved into the cloud was because they wanted to give their developers, their operations teams, agility to build new solutions, to digitally transform themselves quickly, to stand up these storefronts or customer-facing applications very, very fast compared to previous generation of things. As they went about doing it, the problem that it has created is that cloud is essentially a self-serve type of model where everyone can spin up their own things within an organization.
Right.
So from a finance team's perspective, they need to be able to attribute cost to various different cost centers, right? Like, so is this application belong to this team in this business unit, just to measure, call it activity-based costing, call it measuring the P&L of various different parts of the business, and so on. So So one problem that is always that came about with the cloud was the ability to attribute cost to every different team within an organization. Because if you could measure it, then you can at least tell these teams like, hey, you're spending this much money, and this is going up, going down, staying normal. And also from a financial reporting perspective, being able to at least internally have an idea of where the money is being spent when you spend money on the cloud. And especially when you're spending hundreds of millions, billions of dollars, it becomes very important.
Right.
So the problem with many of the solutions that were built in this area was that they were built to try and attribute the cost of the cloud to various teams, but they have no way for these teams to act on these costs. So, for example, you're a team, you have 50 engineers, maybe 100 engineers working on the team. You're suddenly told, okay, you are spending $50 million this year. Last year, you were spending $25 million. Go fix it. Go fix it, make it better, make sure it's optimal, et cetera, et cetera. So the insurmountable challenge for the teams is that they don't even know where to start. Like, yes, the cost is attributed to them, but they don't even know where to start, where the top low-hanging fruit is, where they need to optimize the cost first and second and third and so on. At Datadog, what we do is we go fine-grained, because we are already monitoring all of these resources for the teams. We go fine-grained, and we can associate the cost of every, like, what is attributed to a team down to the level of every single resource that team uses. So that team can then very quickly sort and see where the biggest cost drivers are, what is growing the fastest, what is growing the slowest, down to the level of the server, the container, the host, right? Like just down to the level of that, which then helps them kind of understand that, okay, what am I looking at? Where is the cost coming from? And then they can drill down, because the performance data is right there. They can drill down and look at the performance data right in context. So I'll give you an example.
Okay.
So let's say you're looking at the cost and you say, oh, all these servers that participate in this application, their cost has gone from 100 to 200. So you say, why is that? So you click on it, and it shows you that you changed from class A machine to class B machine, which is more expensive, right? Like, so it shows you that. But in addition to that, it shows you how much CPU is being used on that server, how much memory is being used, et cetera, which immediately tells you that, oh, you moved to this new server that's costing you a lot more money, but maybe you're not utilizing it at all. You're not utilizing it at all. So you are better off using the cheaper one because you are utilizing it better, right? Like, so CPU usage was 90% on the old one, it's 20% on the new one. Then you're asking yourself, why am I wasting 80% CPU? I could just use smaller servers. So it's that level of granularity that we go down to by combining the observability data with the cost data.
I'm thinking of there's an ideal version of this product, and maybe this product already does this, where the people using it can look through the data, they can look through the columns, and they could say, oh, this is a problem, that's a problem, we spot that. Does the product, or will the product in the future play almost a proactive, predictive role, where the application itself says, hey, we know you're wasting X amount here, X amount there. We're actually going to tell you what to do. Is it at that level, or not quite yet?
It gives you a fairly good indication of that, good indication, because what we do is when we provide you the cost data, we lay out right beside it what is contributing to that cost, and we sort it so you can start from the biggest factors to the lowest to the lowest drivers of cost. So you can start at the top and you can say, okay, look, this is where most of the cost is, and what is causing this cost to occur. We can show you side by side exactly what's happening. So it's almost, I wouldn't call it like what is going to happen in the future from this,
Mhm.
but you can get a very good indication of trends, for example, because our performance data, the way we do performance analytics, we are actually able to forecast how something will perform tomorrow based on how it's performed today, yesterday, day before, based on a trend line, right? Like based on,
Right.
not only that, we can even look at seasonality to look at month over month, week over week, year over year type of comparisons to understand like how did this perform on this day of the year today, right now versus last month, the same day, et
Mhm.
cetera, et cetera. So that allows us to also be able to predict the cost in the same kind of vein, because it allows users to see exactly how much it's going to
Mhm.
cost, because performance and cost are two sides of the same coin.
Right. That makes sense. All right. So speaking of the future, let's take a look at the future of infrastructure monitoring. Feels like the sector is closer to its infancy than full maturity. Correct me if I'm wrong on that, but the real question is what is infrastructure monitoring going to look like in the years ahead? What about the role of AI? What do you see there?
Uh, it's a very exciting and very wide open future in my perspective.
Mhm.
Now, while I don't have a crystal ball to know exactly what it's going to be, but I do know that it's going to be much bigger and much more uh, with many more things that we don't do today very well as an industry that we'll continue to evolve and do better on.
Mhm.
So one of the ones is much more of a use of AI and predictive analytics,
Mhm.
and that comes with gathering much more data, because it's a very data-driven approach. Uh, the more signal you gather from various different sources, the better you get at predicting what's going to happen, because you can see much more. So that's one area that I think is going to be much better. One area that we have done uh, uh, that where we've made a big investment in, that's doing really well, is root cause analysis, where you are you're looking at observability, and specifically observability of, like, you're looking at data from various different systems and understanding specifically what the root cause of that data is. So for example,
Right.
if there's a problem, being able to understand the root cause of what caused that problem. Because in modern world, many applications, developers check in the code today, within a couple of hours, sometimes even, that code gets deployed into production. And if it causes a problem in production, being able to take that data, take that problem that happened in production, and trace it all the way back to a specific line of code that a developer checked in,
Mhm.
is really where we're going to in one area, right? Like one area of observability is where we're going to. The other areas that I'm personally very excited about is just the ability to do root cause analysis in modern applications. Developers are very agile, and they check in code multiple times a day.
Mhm.
And from the time that someone checks in a code to the code hitting production, it can be hours, um, from check-in all the way to code getting deployed in production.
Mhm.
Now, many times the performance issues that happen in applications or on infrastructure are related to code changes, and the ability for observability to go back and trace back um, a problem in production, which is like, an application not performing properly or something being down,
Mhm.
right back to a configuration change or a code change that was deployed recently, is a very exciting area. We are investing a lot in that. We've already developed some products in this area that allow you to go right back and look at exactly what was happening that caused the problem to occur. So that's
Mhm.
one area.
Okay.
The other area that's super exciting and interesting is the area of product analytics. Like as we talked about before, digital transformation and your customers now using your website, your web applications as the storefront that they interact with you through, means that you have to be able to understand exactly what your customers are doing, whether they're getting frustrated, whether they're getting a good experience, and so on and so forth. So observability also encompasses understanding how your customers are engaging with you through your products that you make available to them on your website, which may be, like in a bank's case, an online banking application.
Sure.
In an e-commerce website's case, like how you check out something. So being able to do the product analytics to understand exactly what is happening within an application, how the customers are doing, and bringing that into the mix with observability data is another key area. And the third area that I think we are expanding into very rapidly is the area of security. Security specifically around these applications, because observability is just observing what is happening with an application. Now, traditionally, the lens that we have looked at what is happening with an application has been through the lens of performance and availability, whether the application is up and running or it's down, whether the customers are able to log in quickly or they're waiting around for a long time, right? But the same data, when looked at it through a different lens, which is security, can tell you a number of other things. Oh, my customers are not able to log into the website because I'm getting a distributed denial of service attack, for example, which is the same monitoring data, but looked at it through a different lens where you say, well, usually I have 10,000 network connections to my site, and right now I have 1 million somehow, and that's clearly an anomaly, right? Clearly a security-related anomaly. Similarly, looking at things like, oh, my application is not performing so well, and that's because a SQL statement is taking a really long time to run, right? Common problem. But maybe the SQL statement is taking a really long time to run because there's SQL injection and data exfiltration happening on the website, which you normally don't expect. So that is the type of stuff that we are looking at to understand, like how, and these are just simple examples on how observability is bringing together not just performance and availability of applications, but also the user's interactions with these applications and how that affects the business, as well as the security of these applications, all in one place.
Amit, that's interesting, and there's a lot there. I think you said it. Thanks a lot for sharing your insight today, and please come back and talk with us again sometime.
Thank you very much, James. Really appreciate you having me.